Today we are going to look at how to solve a linear system. So first we are going to take a look at how to do that by graphing. So you may recall from grade 9, or if you watched my previous video on how to graph a line from slope-intercept form, then you should know how to graph a line. So when you are given a line in slope-intercept form, which is y equals mx plus b form, to graph it, you are going to first plot the y-intercept. Okay, so this is going to be the point that is on the y-axis. And we can tell what that point is from the b value of the equation. So we're going to put that point at 0, b, whatever that might be. Okay, so that is our initial point. And then the second step is to use the slope, which is the m value, and it's equal to the rise over the run to plot at least one more point. And then you can connect them. Okay, if you want some more details on how to do that more in depth, there is another video on my page where I will show you kind of step by step how to do that. But that's the main idea, is that we're plotting the y-intercept, and then from that, using the slope, using the rise of a run to go up and over, or down and over if it's a negative slope, to find another point, connect them with the line, and then you plot your graph. Now, sometimes you are given an equation of a line in standard form. Sorry, this should say, how do you graph a line given in standard form, not given. So standard form of an equation is ax plus by equals c, which you may have seen before, maybe you haven't, but essentially it's the equation of a line. It's just rearranged a bit differently. So your x and your y variables are on the left side of the equation, and then you have a variable, which is just a number, on the right side. And from this form of the equation, you cannot tell the slope or the y-intercept just from looking at it like you can from slope-intercept form. That's a common mistake, is just looking at it and thinking, okay, whatever number is for A, for example, attached to the x is the slope, and C is the y-intercept, but that's not the case. So what you need to do is you need to rearrange the equation to look like y equals mx plus b, and then you can graph with the same steps as above. So when you have ax plus by equals c, the first step is you want to bring the ax term to the right side. Okay, and you're going to do this by either adding or subtracting on both sides. Just depends on what the sign is of your a coefficient. Okay, so like let's say it was 2x, you would subtract 2x on both sides. So then you would have by equals negative ax plus c, or if it was a negative already, then it would be a positive. And then you will divide all three terms by whatever your b value is. Okay, because we want to have it isolated for y, so you need to divide by whatever b is, and then you will get your equation in slope-intercept form, y equals mx plus b, and then you can graph using your steps above. Okay, so I also showed how to rearrange and do this on the video lesson that goes more in depth with how to graph, and I will show an example in a moment as well. So we need to know how to do this. We need to be confident with graphing so that we can solve a linear system. So a linear system is a set of two or more linear equations. When we are working with these, it's typically just going to be two equations. Okay, so you would be given two different equations of lines, and when you solve it, it means that you find the point of intersection. which I will just abbreviate as POI. Okay, so when you see me write that, that's what that means, point of intersection. So when we have two lines graphed on the same plot, there are three ways that they can intersect. So if you have a line like this, a line like this, really like any two lines, they will eventually intersect at one point. We sometimes have parallel lines, which we talked about before, which have an identical slope, and this means that they will never touch, so they could intersect at 0 points. Okay, if I show these little things here, that means that they are parallel. Or a rare case, we won't really see this because it's not going to help us with anything, but it could be that it's the exact same line, and so it intersects at an indefinite number of points. So if it's the same line twice, essentially, like if you were to rearrange and you get the same equation, then there are infinite points of intersection, because every single point on that line is going to be the same because the line is the same. The most common solution that we will see is the 1 point of intersection, because that's what we can actually solve with the methods that I'm going to show you. However, occasionally we will see where there are 0 points of intersection with parallel lines when we're investigating shapes that are plotted on a Cartesian plane. So if we take a look at an example of this, we want to solve the following linear system by graphing. So you see we have two equations of two different lines here. So we have y equals negative x plus 7. That one's already in slope-intersect form. And we have 6x minus 3y equals negative 3. So the first thing I'm going to do is on my grid here, I'm just going to draw my axes. If I'm asking you to do this on a test or anything, I will give you the grid and then you can draw on it just so that everything is a little bit more exact. Okay, so this is my y-axis, this is my x-axis, and I'm going to show what I'm going up by here. I'm actually going to just move this down so that I can have space to do both of my equations. Okay, so let's say here I'm going to go up by 1s on this axis. I'm just labeling every second line so that I don't have to write as many numbers. And then same thing here. Okay, so if I take a look at my first equation here, it's already in slope-intercept form. So my y-intercept is 0, 7, okay, because my b value here is 7. And then my slope, there's no number written in front of the x, but when that's the case, you can assume that it's a 1. We don't need to write the 1 as a coefficient because it's kind of redundant. So if there's nothing, if it's just x, then it would be positive 1. In this case, it's negative x, so our slope is negative 1, which we could represent as like negative 1 over 1 if you want to see it as a rise over 1 version of the slope. So the first thing we're going to do is plot that y-intercept, which is at 0, 7, so right here. And then we're using the slope, negative 1 over 1, to get a few more points. So again, we know that negative 1, that's a negative slope, so the line's going to be decreasing towards the right. We're going down 1, right 1. Okay, so we could put another point here, then here, and we could keep doing that to do as many points as we need. And that would give us a line that goes like this. I'm just going to connect them. If you have a ruler, it's great if you can use one just so that things are a bit more exact. If not, that's okay. Just try to make your line as straight as you can. Okay, but when you're graphing when you're solving by graphing, it is pretty important that your lines are accurate. Otherwise, you might not be able to see the point exactly where it should be. Okay, so that's the first line. That one's pretty easy to graph because it's already in slope-intercept form. The second line, we need to rearrange it. It is in standard form, so we need to do some isolating to put it into slope-intercept form so we can graph. Okay, so the first thing we're going to do, we want to bring this x term to the right side of the equation. So I'm going to subtract 6x here and subtract 6x on the other side. Now I'm just going to show it to you like this for a second. So negative 3y equals negative 3 minus 6x. The important thing here is that you're not subtracting 6x. Like, you're not subtracting 6 from negative 3 because those are not like terms. So a lot of times students will write it like this and then think, wait, this doesn't look like a line. But it doesn't matter what order you put the numbers in as long as you keep the signs the same. So you can just rewrite this with your right side in the proper order so that it looks like an equation of a line. So this would just be negative 6x minus 3. Okay, I just usually write it like that to begin with, but sometimes people get confused as to why I can just do that. But it doesn't matter what order you write the numbers in. Like I said, just keep the signs correct. Okay, and then I have negative 3y, which I don't want. I want just y, so I'm going to divide by negative 3 here. And you need to divide all 3 terms by negative 3. Okay, so typically people know that you're dividing by negative 3 on both sides, but what that means on the right side, you can't just, if you're dividing this entire side by negative 3, then all of the terms need to get it divided by it, otherwise it's not correct. Okay, so every single term, all 3 of them get divided by whatever number is in front of y. Okay, so this negative 3 divided by negative 3 will cancel out. We will have just y, which is what we want. Negative 6 divided by negative 3 is positive 2. The x just stays the same. Okay, you don't have to write x over 3 because it's just the numbers that get divided. And then negative 3 divided by negative 3 is positive 1. Okay, so this is now in slope-intercept form, so I can tell what my slope is and what my y-intercept is. So the y-intercept, because my b value is 1, that means my intercept is 0, 1. And my slope is my m value, which is 2. And again, if you want to see that as rise over run, if you have a whole number, you just put a denominator of 1. So we can say the slope is 2 over 1, which means we are going up to right 1. Okay, so I'm going to plot that on my graph. So first, my y-intercept is going here at 0, 1. And then I'm going up to over 1. Okay, and I'm going to do that once more, up to over 1. You can see here that's going to be where my lines intersect. And then I'll just do it, or I'll just connect these with my line now. So I'm going to start here. Just connect these with a nice straight line. Just extend them. Make sure like you extend them far enough that you can see where they intersect. In this case, it's fine. But depending on what the lines are, if you don't extend the line far enough, it might not look like they intersect. Okay, so then now we can see that right here, this is where those lines intersect. That is my point of intersection. So the question was asking me to solve the linear system. So what I need to do is determine the coordinates of that point. So if I just look at my axes here, this is at 2 on the x-axis and 5 on the y-axis. So what I would write for my solution is I would say, like you can just write therefore POI, which again is point of intersection, is 2, 5. Okay, so your solution should be stated as a coordinate because you're finding that point, the coordinate where those lines intersect, and that is how you solve by graphing.